Okay, hi everyone. This is the second part of section 14.4. And we check the last assumption that the independent variables should not be correlated. Why? Okay, let's say you want to find out if a certain diet affects your weight. Okay, now if you at the same time that are doing that diet, if you also go and exercise, those two variables, usually that's the exercise and diet, are very much correlated with each other. And then you would not know which one is affecting your weight more. So you don't want to have variables that have more than 70% correlation. You don't want the coefficient of correlation between the variables to be more than 70%. So you want your R to be between negative 0.7 to positive 0.7. You don't want to have anything more than 70% or less than negative 70%. So how do I do that? Okay, so the first thing that I do, I go to data, data analysis, and I go to correlation, okay, and put all the independent variables, only the independent variables. Look, I did not put the dependent variable in there, only the independent variables there. Okay, and now I check all the independent variables. Okay, it seems like, okay, English with high school 60%, it's okay. This is getting close, 63%, but it's still okay. None of those are more than 70% or less than negative 70%. Okay, so it seems like it is okay. Now remember, this is a two-part process. So that's number one. Number one, we passed. Now, number two, what we do, we have to find something called VIF, variance inflation factor. And once you find that, your VIF, the criteria is it should be less than 10. How do I find that? Look at this again. I have only my what? The independent variables. So now, if I want the VIF for high school, okay, I assume high school is my dependent variable. So this is what I do. I go to data, data analysis, then regression. Okay, I'm getting the VIF for high school first. So high school GPA, even though it's independent now, I assume that it's my dependent variable and everything else is my independent variable. Okay, I don't need any of these, don't need any of these. Okay, G1, let's put it in E1. Okay, and look at this, 1 minus 1 over R squared. So the VIF for high school GPA is equal to 1 over parenthesis 1 minus R squared. That's the R squared. Is that more than 10? No, so this is okay. Okay, so now I want to get the VIF for English placement scores. So I cut that, put it here, insert cut cells. So automatically that came in first. So now I go to data, data analysis, regression, everything is okay. Now this is my English first as a dependent variable, everything else as an independent variable. I just don't want to put it in E1 because it's going to overwrite that. I put it somewhere here, E22. Okay, so this is my R squared. So now I want VIF for my English score. So that would be 1 divided by 1 minus Click on the R squared. And is this value more than 10? No, it's supposed to be less than 10. So this is also okay. So far I don't have no problem with collinearity. Last one is math placement test. So cut that, insert cut cells here. Okay, so now I have my math placement test as my dependent variable, data analysis, regression. Everything is there, don't need to change anything. This is my dependent math placement test. These are my independent labels. E22, I want to change that E22. I don't want to put it in E22 because it's going to overwrite this one, so I put it in E42. Okay, so this was for high school GPA. Sorry, for math placement score. So that's for math placement score. So this is my VIF for math placement score. Okay, equal to 1 over 1 minus R squared. Is that less than 10? Yes, so that is also okay. So I checked the correlations. None of them are more than 70% or less than negative 70%. I checked the VIF for each variable. All of them are less than 10. So I don't have any multicollinearity problems. That means these scores are related, but it is within the range. It's not too correlated with each other. So this is the end of your section 14.4.